We're gonna explain today how to do line balancing and facility planning. So we're gonna consider the example: a sample an electric appliance assembly area is shown in the figure below with potential workstation A through F. The task must be done along with the respective time indicated in the precedence diagram. This is the precedence diagram. The machine scan is automatic and come anytime after task 2. The manufacturer desired output. Okay, let me explain a little bit. So we have the product as it is with its steps is distributed in the precedence diagram from step 1 to step 10. With those numbers is standard time. Standard time is a processing time, so it's like 1.1 minute per unit, 0.4 minute per unit, 0.5 minute per unit, all the way till the end. And in a factory we have several departments, about 6 departments: A, B, C, D, E, and F. And we, as if department, as if it is like empty space in an area, and want to do those tasks within those departments. So we have those 10 tasks, we have to distribute them, to lay out them within those departments, okay, which is A, B, D, E, and F. Alright, or we have 6 workers, so it could be department or workers, so we have to relay out, to reschedule the job, to distribute it among those people. And we have to out is 367 units per 8 hour, and we stop the line for 20 minutes break in the middle of the morning and afternoon. So we have 20 minutes break, which is like 40 minutes, and 8 hours a day, so total available time is 367 minutes. So I'm gonna enable minimize button, slideshow, set up slideshow. I'm gonna enable the pen. So we have here 367 units must be produced per day over 8 hours, and we're gonna deduct 20 minutes break from the morning, another 20 minutes break from the afternoon. So the remaining time is 300. Okay, so the remaining time is, excuse me, 480. It's a little bit difficult to write with this pen. Minus 40 minutes, so is equal 440 minutes. Okay, and the cycle time, so we must produce the 367 units in 440 minutes. So the time available per unit is 440 divided by 367 is equal 1.2 minute per unit. So in a way we have, if we're standing right at the end of this box of this factory, we might expect to see a unit exit the system every 1.2 minutes. And so I'm using the mouse to write on the screen, the PowerPoint screen. So the total time available is 480 minutes minus 440 minutes, and the cycle time is 403 minutes divided 362, so 1.2 minutes per unit. So we might expect to output a unit every 1.2 minutes in order to achieve 367 per day. So let's see how we're gonna split those tasks to distribute them within the factory. So we start with workstation A. One of the conditions they say us, the machine scan must come after task 2. So we must have 1 and 2 within A, B, and C. This is obligatory. So we're gonna start with this system. We have this one as station 1 or station A. So we have task 1, and the total time is 1.1, and the idle time is 0.1 minute. This is the first step. For the next we have 0.4, 0.9 is, and 0.3 is 1.2. So we could fit all this to be in one box or to be done per one worker. So for the machine B we have the 2, the 3, and the 4, and the total time is 1.2 minutes. That's summation 0.4 plus 0.5 plus 3, and the time here is 0. Okay, for step C is 1.2, so it will be step 4, 2, 3, 4. Excuse me about this, but here is step 5. So 1.2 as well, and this one is 0. Okay, and this is D. And the idle time is 0. What's meant by the idle time? If you expect to see a unit exit system every 1.2 minutes, so if, for example, if worker which is allowed, which is on station A and he's doing task 1, if he finishes the job in 1.1 minute, he still got 0.1 minute to be idle, which means like he's sitting, he's not doing the job because he has idle time, so in a way like a free time. And step 7, and step, this is BE, and this is F. And I have to remind everyone that I'm writing using the mouse on the PowerPoint. You could see the video related how to write on the screen. So this one is 1, and I have 0.2. And for step 7 is 3.4. Okay, so for step 7, which is 3.4, is the 3 time is way more than 1.2 minutes. If step 7 is very time consuming, for example, if I am on step 7 and I am in charge of step 7, it takes me 3.4 minutes to do 1 unit. Therefore, I need, in order to achieve the output of 1.2 minutes per unit, I need more people to help me. Okay, I need more people to help me, and exactly 3 people to help me. If you're working like 3 people, instead of if you're working like as a 3 people, therefore we have as a time cycle time 1.2 minutes. So 1.2 minutes for 3 people is 3.6 minutes, or we do 3 units. Okay, so in this way, because each unit will require 3.4 minutes, so we need the idle time will be 0.2. I'm gonna re-explain this. If I am on step 7 and I need 3.4 minutes per unit to do the job, therefore I need 2 other people to help me in order to reduce this value to 1.2 minutes per unit. 1.2 minutes per unit, and 0.2 minute idle time for all 3 of us. Okay. And it's very simple. Like if I do the job in 3.4 minutes, if 3 people were now working, therefore in every we do this job the same amount of work, 3.4 divided by 3. Okay, so the total idle time in this system is 0.1, 0.4, and 0.5. So the total idle 0.5. The total idle time is 0.5 second or minute. Okay, and the number of labor is 1 for machine A, 1 for machine B or step B, 1 for step C, and 1 for step D, and 3 for step E as we explained before, and 1 for step F. Therefore we need 8 people. Okay, and if you want to measure the efficiency on the system, how efficient the system is, efficiency is equal 1.2 times number of labor 8, 1.2 times 8, okay, times 1.1, 1.2, 2.4, 3.6, 3.6, 7, 8, 9.1 is the total required time this one here equal 9.6. So 9.1 divided by 9.6, this would be our busy percentage. Okay, so the objective of the line balancing is to reduce the idle time is by reallocating tasks to other reallocating tasks. Therefore we reduce the idle time greatly in a system. Okay, but before we stop, I just want to do a few things. What is the busy efficiency before line balancing and after line balancing? Okay, so this one is 95, almost 95%, and this is with line balancing. And utilization efficiency without line balancing. Without line balancing, we just need like 10 people, so it's gonna be 1.2 times 10, and here 9.1. okay, so 9.1 divided by 12, so it's 75%. Okay, therefore it's crucial to do line balancing. It's crucial to do line balancing in order to minimize the idle time over the whole system.